Well, we're a community group from Monmouthshire, basically. We started out 10 years ago with the idea of putting a wind turbine up on the Gwent levels. We had a retired school teacher who was good with letters, so we eventually gave that idea up. So we set up about 10 years ago to build a wind turbine, which didn't come off, so we then got into solar panels, basically for community centres. And we've helped about 70 community groups put them on. Quite a few didn't want to do it themselves, so we've got an investors club of local people which loan us money, and we then use that to install them on the buildings for the community organisations, and then we get the tariff to pay the investors and help run the company. So at the moment we've got about 19,000 people that use the halls that's got our renewables on, and just about all in deprived areas. All funded by a local investor club. Right. And there's two of our schemes. One on the left was a particularly interesting one. 24 kilowatts on a church in Cardiff, which was quite a tough job with the slope and things. And in the back you can see my daughter at the top just finishing off, so it's a family affair. On the right is a biomass boiler we got in Wellington. That's on another church community centre. Anyway, let's talk about batteries. I think that's what we wanted to do tonight. So those are things. We have a brief introduction to it. Who would benefit? Two main types of storage. We'll talk about the main components, a little bit about types of batteries, and then a bit costings, and then a community model. This is the chart from one we installed 2 years ago. I think this is the annual chart. So, is that the annual? No, it's the day chart, sorry. The yellow is the one, that's the house consumption over 24 hours. The yellow is the output from the solar and how much is going into the house. The blue is what's coming from the battery, and then the red is what's coming from the grid. And they only get anything from the grid if they put the kettle and toaster or the kettle and the cooker on at the same time. For about 4 months of the year, they've got no import whatsoever. And on top of that, they've got an electric car to charge. It's only a Twizy, but it still takes a fair bit of power. So they're quite conscientious of what can be done. And in the summer months, their electricity bill is usually between £1 and £3 a month. Goes up in winter, but we'll come to that in a minute. So yeah, brief introduction. You basically saved unused generation for later. So during the day your solar panels produce more than what you use normally. So we use that to go into a battery. We monitor the incoming power connection, and we try and keep the power coming in and out of the house of 0. And we do this by, if there's surplus power, we charge the battery, and if there's not enough from the solar for what you're using, then we discharge the battery. So the idea is you keep the power coming in and out of the house at 0, so you pay nothing and nothing goes out. And we do this there's an inverter charger that does this controlling as well as the batteries. So here's a one-day chart from a Victoron system. This is when they are discharging at night. They're using 1.6 kilowatts in the house, evening I think by the look of that, 28 kilowatts from the PV, 9 kilowatts from the grid, and the rest is coming from the battery. So that's trying to keep their grid at 0. Doesn't quite get to 0, it'll be a few watts either way because it can't quite get there. But that's what we're trying to achieve. So who would benefit from battery storage? Anybody that's got surplus generation in the day and you've got consumption at night. It doesn't happen for domestic, but for commercial users, you may pay extra power during peak times. And the battery is extremely good at keeping that cost down because you're charging it up in the day on free electricity and then you get it back at the peak period. Now, buildings with a lower night rate than a day rate, like an economy 7, they could potentially benefit from batteries by charging up at night and using it in the day. But at the moment, the economics on that is a bit borderline. So we haven't actually done any of these, but the theory is there. So if the electricity prices go up much more, then it could well become more viable. The last category of person is anybody who needs an uninterruptible power supply. So if you've got medical equipment that you need to run if you're in case of a blackout, then battery storage could be a good solution. This is another type of system. This is a grow watt system which is on the DC side. This was one of the first we put in. This takes power directly from the panels and goes into the battery. Well, goes through the inverter first, into the house or into the battery, and only then does it go out to the grid. Now, a DC solution like this has one problem in that it'll reduce the total generation that you get on your generation meter, because there's a little bit of loss going in and out of the battery. So if you're on an earlier tariff at a good rate, we wouldn't put this in. But if you were putting panels in now, and you're on the low tariff now, it's probably the cheapest way to go. It's a cheaper solution than the other. But you lose a little bit of generation. But now if you put solar panels on the house, you're only going to get about £200 a year if you're lucky out of it from the tariff. It's, you know, hardly worth claiming now. If you've got any questions directly related to this, please jump in, I don't mind. Yeah, so we've got two types of storage. We've got the DC side, which takes power directly from the panels and then generates it through your existing inverter when you want it. And an AC side, where you connect on the mains side, completely independent of your PV panels, and those systems can be much bigger, more flexible. You can put more batteries on them and various things, but a bit more expensive. So the DC one is good for small domestic systems. If it's just, say, 2 people in the house at night or something, then a DC solution is pretty good. But if you've got a big house with 6 people in there and teenagers up all night, you probably want to go for the AC one. And the AC has more functions. We can put a blackout power on it so that we can run part of your house in a blackout. Where we live, there's not much call for this because the power supply is pretty regular. But if you do it in a poor area, it could be worth doing. Yeah, that's the AC side solution. That's Victoron, which is a Dutch manufacturer. No size on limitation and things. It can be very big, but it's a bit more complicated and a bit more expensive. But they do work really well. Right, main system components. A current monitor at your import meter to measure whether power is going in or out of the house. That's the most important piece of equipment, so as you know what's happening with the system. That then goes to a controller, which then determines whether it puts power in the battery or pulls it back out. And the last main component, of course, is the batteries. On the batteries, sizing them depends on a few things. We generally work on the basis that Your consumption overnight, if you use, say, 2 units of electricity at night, we'd probably recommend about 4 units of storage. So you've got a little bit of reserve, but you can go bigger, give you a bit more power on bad days and things. But that's about what we would look at. This is one I prepared earlier. It's a Victoron, and there's 2 inverters there. It's on a farm, so there's 8 kilowatts. He didn't want to spend a lot of money, so he's got lead acid batteries, but lead acid outside doesn't work very well in the cold weather in winter, so we don't really recommend lead acid if we can. And also fairly bulky, because that's only 4 kilowatt hours of storage. If we went with a lithium one, it'd only be about a quarter of that size for the same storage. And it works better in cold weather. Yeah, so in the picture back there, we got the Victoron 7 kilowatt hours of lead acid battery. Lead acid, you normally only discharge them to 50%. If you discharge them fully on a regular basis, they won't last long. They'll, probably 6 months you'd finish them. So one thing with the inverters is you must tell them what batteries you've got, what type of batteries, what the size are, and then they will look after the battery. They will then control the charging and discharging to maximize the life of the battery. Yeah, 8 kilowatts of solar on there, 7 kilowatt hours of storage. Yep, move on. Yep, those are 2 types of current sensor. The one on the far side, that measures PV power and your power consumption. Where we fitted them, sometimes they've had a wind turbine as well, so it can measure that as well and bring it all in. The one in the middle, that's just a single current sensor on a wire, which is a fairly cheap one, but it only measures the power. It doesn't give you quite such a good picture of what's going on. And the one on the right, that's a Wi-Fi one. If you've got a long distance you can't run a wire across. But we've actually stopped using those Wi-Fi connections now because they've turned out to be a real Achilles heel. Keeping that Wi-Fi connection is essential, so we've done away with them and we only go with hard wire on them now between the current sensor and the unit. I just get fed up, keep going back and resetting it, and it's not the way to go. At the moment, we take the view that there's 2 types of battery, the lead acid or the lithium. There are some other exotic animals about, which we've decided to let other people try for a few years and before we'll go into them, like the saltwater battery. Potentially they're good, but they're a bit unknown and we wouldn't put that on anybody's installations till we get more confidence in them. So the lead acid, it's a cheaper battery, but it's got a short life. The lithiums, they're much smaller, lighter to handle, and we should be looking at about a 12-year life on them. But the life is done on cycles. If you drain them down fully every day, you'd probably be around 9 to 10 hours, 10 years. But on a normal usage, we should be looking at about 12 as a reasonable life out of a lithium battery. And how do I know this? Well, I've got an electric car with a lithium battery, which is 4 years old. We've done 70,000 miles, and the battery gets charged and discharged at least once a day. I've lost a little bit of range, but it's not significant yet. So we do know that lithiums work quite well, last quite well. And these days, I don't think we would recommend lead acid at all because it doesn't work very well in winter. And with the drop in lithium price recently, it's lead acid is probably not not the way to go. And environmentally, lead is not a desirable product. So yeah, we wouldn't go with lead if we can. So that's a picture of the two types of battery. On the right is a lithium, and on the left is a lithium, on the right is the lead acid. They're not quite to scale because that's 4 kilowatt hours, and that's about 1 kilowatt hour, the lead acid. So you can see there's much bigger volume in the lead. Yeah, life of battery, it's related to usage. This is always a question everybody asks, is how long the battery is going to last. If you choose a lead acid, I don't think I'd give you much confidence that it would last much beyond a year or maybe 3 years at most. Depends how you treat it. If it's a lithium, I would expect, if you discharge it 50% every day, we should be looking at about 14 years out of it. The lead acid, I said 7 years. That might be a bit optimistic, actually. I think they're turning out to be less than that. If you put in a bigger battery pack than the minimum, if you put in, say, twice as much battery, you get a lot longer life because you're draining them down less. Your life cycles are going to be much longer on them. So people always ask, what's the price of the storage? Well, I can give you the price, and they want it nice and cheap, but having a little bit extra battery is usually well worth it. And it costs a little bit more, obviously. That's that's a 10 kilowatt hour of lithium, and it's like a bedside cabinet. If you compare that with a similar size of lead acid, would be probably about the size underneath the table over there. So it would be 3 to 4 times the size of it. That was installed for somebody at Brecon who works in Cwmbran, and they've got an electric car. So they travel to work every day, and when they come back in the evenings, certainly during the summertime, the solars charge that battery up, and they get their car fully recharged for nothing. But it doesn't work so well in winter. Yeah, systems, they're rated in 2 ways. One is the output power of the inverter, because you get inverters of different sizes, so you can have 1, 3, or 10 kilowatts, and that determines how much power it will produce at any one time. For a house, you would generally put a 5 kilowatt in, because that will meet most of your peak power needs. If you put a smaller one in, and you've got a high demand, you might not be able to drain the battery down fast enough to meet it. And the other way of storage capacity, usually in kilowatt hours. So kilowatt hours, 1 kilowatt for an hour, and as we said, we generally look at them about twice what your evening consumption is one way of rating them. Right. Right, this is one chart from the house earlier in the year, earlier in the display here. This is over 4 months, first 4 months after it was installed, which was in the summer. And you see the yellow again is what came from the solar. The blue is what came from the battery, which had been saved the previous day. And the red is what they imported. So you can see the effect that the battery has had. It's cut their import by about 80% from what they were importing previously. So they're typically looking at £2 to £3 a month for electricity in the summer. In winter, not so good. So, benefits of storage. All generation can be used on site. Reduces your bill. How much you actually get out of them is very difficult to predict, because you've got the variability of your solar output, you've got the variability of your consumption, so those two gives you quite difficult to predict how much power you're going to put in your battery and save you. We used to say you get about 3 kilowatt hours a day out of a 4 kilowatt hour battery, but I think our experience over winter is you probably get less than that. You're probably only getting about 2 kilowatt hours out of a 4 kilowatt hour battery, because you get that much lower generation in winter. So battery is not really a magic bullet to get rid of all your bills, unless you put an awful lot of batteries in. So the return on a battery is probably about 5%. If you've got money in the bank at 0.5%, well then it's obviously much better, but it doesn't work if you've got to borrow the money. Right. There's another one we done earlier. That's a community centre at Blackwood. Put thin film panels up there, and they've got a battery inside, which then covers them for their night consumption. It works quite well for them. But of course, one of the problems with halls, village halls, unless they're in use every day, you don't get the benefits fully on from it.
Do the thin films last? They last these days?
Yes. Yeah. We would only fit thin films if I had a choice, because you get about 15% more power out of them, and you get it at the low light conditions. So thin film's a really good panel to go for, and it's pretty much the same price as a crystalline.
And they last the same amount of time now?
Probably longer.
Yeah.
Probably longer. The only difficulty at the moment is nobody is importing them, so if we put them on, we've got to bring them in from Hungary ourselves, and manufacturers are not bothering to put MCS accreditation on because there's so little demand. And I don't know why, because we've got quite a few of these and they work really well. We've been very impressed with them. Yep. Yeah, there was a little example of a village hall. 6 kilowatt of solar, 7 kilowatt hours of storage, would cost about £10,000. At Salim, I think it was about 15, because it was a bit bigger solar on that. At the moment, fit tariff is about £190 a year. If you were selling it to the hall, you'd probably get about another £400. So the income would be about 597. So this is a model for a community group that wanted to put it on a hall and fund it and get repaid out of it. So if you did it with a share issue at about a 3% dividend, it just about works, but it's not lucrative. It's not like the early days of solar panels were, unfortunately. And there's one we did, this was the very first battery we did maybe 4 years ago now. And what we've done there is we've taken over the house electricity supply. We put 4 kilowatt hours, 4 kilowatts of battery on, and 4 kilowatt hours of lead acid in there, and we supply their power completely. And we charge them 10p for all their electricity, so that gives us our income. So they got cheap electricity, and we pay for any extra imports coming in. And it works quite well, but if you look down here at the bottom on the figures, you can see here, in 1 year we still exported 1,700 units. We generated 2,000, and I think we imported about 900 because we got the problem of lack of generation in winter. So we exported a lot in summer, But this is a problem with solar, which we're trying to do on a single installation. This is another chart from that house at Brecon.
Can you go back to the mic?
Sorry. Yeah, this is the house at Brecon. That's over 12 months, that is. That's the consumption there month by month. The yellow again is from the solar. The red is what's come from the battery, and the black is what's come from the grid. So if you see there, during the summer, it's pretty well totally from the battery and the solar, but in winter, we just can't do much on it. And we don't really have a solution for that. Because if we put a much bigger battery up there to save it from the summer to winter, much bigger cost, and we get more losses anyway, so it isn't, it's not the total answer. How to design a system? Well, with solar panels, we would generally say you would put solar generation to match your annual consumption. Thereabouts is about the optimum way, because there's no point putting much bigger generation because you don't get paid for it. And if you put much less, then you're not getting the full benefit. And the storage, we reckon about twice the evening consumption is about the optimum size for a battery. So, yep, move on.
Phil, because panels are getting relatively cheap now, could you not just double the size of the panels? You know, just have 8 kilowatts of panels?
Yeah.
That would solve the winter problem.
Yeah, but see, this idea that panels are getting cheaper is not really true, because since we've been in the EU, 4 years now, we've had the minimum import price limitation. So the EU makes all the people importing panels to charge a certain amount. And they haven't dropped in about 4 years, panels. Inverters and other things have come down a bit. The panels themselves, we're paying the same price for a panel now as what we did 4 years ago. People don't want to pay the same price now. That gives us a bit of a problem. That could be one advantage of getting out of the EU with Brexit. Panels will come down in price by about 30 to 40% immediately. So they ought to be 30% cheaper than what they are now, but we're stuck with it. Right? Yep.
When we had our solar panels put in, it must be about 7 years ago now, we were told we were only allowed a 4 kilowatt system because the electric people were saying about hitting the extra electric going into the grid at one time if there's like a power cut or if the lines went down. Is that still the same now? Or can you put 8 kilowatts in, or do you just have to...
That wasn't really true then.
Okay.
The regulation is that you can put 3.6 kilowatts of inverter power on any electric meter and tell Western Power afterwards. If you want to put more on, you just got to tell them in advance and make sure you've got a cable big enough.
Okay.
If the cable's big enough, you can put whatever they say.
Right.
We've put 10 kilowatts on a house if they've had a fairly meaty power connection coming in.
So it's okay to add panels if it's okay with the cables and that?
Yeah. But if you go over the 4 kilowatts, you need to talk to Western Power.
Right.
And in those days, most installers were pretty lazy and just wanted to bang them on without too much aggro. So they said, oh, you can't go over 4 kilowatts,
Right.
which was never true. And so this is a chart of a system not many miles away from here, which Neil helped me to put on. 10 kilowatts of solar and then 4 kilowatt hours of battery. I put this up because we've got generation and consumption on there. So if you see the green line on the left of the chart where it goes up. Oh yes, that's a good idea. Yeah. Over there, you see that there? That's solar power coming from the solar panels. And when you got that green wodge up there, that's charging the battery. Now when it gets to the top up there, the battery is charged, the inverter is now starting up, and it's now exporting power. So most of that is export, which they're not using. But come the evening, they've had an event in the hall. So this is the output from the inverter. So here they started using about 1 kilowatt there for the lights, and that goes on here till about 9 o'clock, and the battery is starting to get exhausted, and you see they're starting to import power then. But that's all they've imported, and that's what they've actually used. So about 80% of the power they've used at that event came from the battery. So that's works quite well, and that was only a week ago, so it was winter production. If you had a chart in summer, which I didn't put up because I thought you'd all shout at me if I did, it looks absolutely amazing. You know, you get lovely nice curves out of it. But yeah, so you can see there how well it works, and all our systems can produce an output like that, so you can see that what's going on, what you're saving and what you're consuming. Well, I think it's time for any questions now. That's just to remind you of me, you see, because you won't forget me now after seeing that. Any? Yep.
Right. Just wondering how, in terms of return on investment, how a battery system compares with something like an Emerson, a low diversion device, whether it's better to install a battery system and store your surplus as electricity, or store as heat by using an Emerson or something similar.
Well, the Emerson is a much cheaper device to put in, but it's only storing the heat, the electricity as heat, and you can't use it as electricity thereafter. So it's not very flexible. But when you put it into a battery, you get it back as electricity, which is a much more valuable commodity per kilowatt. You know, it's about 3 times the price of heat. And if you wanted, you could put it back into heat then. So
but the Emerson is a much cheaper
yes,
device initially.
yeah, you know, it's probably
It's
£400 to
about
£500 you can put an Emerson in, but it only gives you hot water.
Yes, I understand that.
Yeah, you know, whereas this gives you electricity, so you get much. It depends a lot on the cost of what your heating is.
Because in the summer months, an Emerson will give you lots of hot water
Yeah.
using all that energy,
Yeah,
whereas the battery system obviously isn't, because it seems better matched to your needs during the day, basically, than using an Emerson.
well, you've always got the problem that in winter you need more heat, but you haven't got much solar output in winter, because typically your solar panels is going to produce 10 times the power in summer than what you do in winter. And it's winter when you need your heat. You don't need heat in summer except for, you know, domestic water.
Yeah.
And then with that domestic water, the one problem with the Emerson is it'll normally, if you've got, say, 4 kilowatts of solar panel on a house, it'll heat that tank of water up in about 2 to 3 hours, and the rest of the day you're exporting it.
But that's the same with the battery, isn't it? It'll charge
You've got the
battery.
same problem with the battery, but you can put bigger, you can alter the size of your battery, but again, the battery works best if you've got a fairly heavy consumption at night. You know, when it's not generating, that you can use it. If you don't use much at night, there's not much point having a battery. It's a bit hard to compare them sort of like for like, because there's quite a few differences with them, and it depends how you use it and what your house is and things.
Okay, thank you.
Does the controllers automatically, you say the batteries, you should only use them to 80%. Do the controllers automatically shut the batteries off when it reaches 80%?
With lithiums, yes.
Uh-huh.
Because the lithium batteries have controllers in them which tell the, or monitors in them that tell the battery what their levels is, what the temperatures are, and gives you better feedback. The lead acids don't have that. So the controller has to make some guesses of what charge is in the battery, and I know over time they drift and they don't always get it right. So you don't always know precisely what is 20% because it's got no way of knowing.
And would that work alongside an air source heat pump? Because that'd be running pretty much all the time. So would the battery storage be a good solution with that? Because the air source heat pump would be working at night as well as during the day.
Yeah, you know, it would use all that power out of the battery, so that would be good. But you probably wouldn't get enough power from your solar panels into your battery, particularly in the winter months.
Because it'd be running during the day as well.
Because yes, because if it's running during the day, you may not have much surplus to go into the battery, and then there's nothing left for the night.
Yeah.
Could you incorporate a wind turbine?
Yes. You've got to have a slightly different current sensor in there, but yes, we've got 2 of those running with wind turbines.
With solar panels as well, or?
Yes. One problem which we found, which we haven't yet completely solved, is with a wind turbine, because their power is fluctuating, the battery controllers don't respond fast enough to keep changing the charging levels. So if you've got gusty conditions, you only get about, maybe about half of what your wind turbine going into the battery, because it's too gusty for the controller to keep adjusting for. But with solar panels, you get probably 90% of it. It'll respond much faster.
The efficiency, solar panels at 20%, wind turbines can go up to 70%.
Well, this efficiency is one I could talk all night on because it's.
Can you just tell us what was said?
It was just. Do you want to repeat that?
Yeah, so I was just talking about efficiency of both systems. So the solar panels, it's very difficult to cross 20% of the efficiency of the system, but the wind turbine can go up to 60, 70%. So if you're using it less, then the final figures, they might match in certain situations. But
Yeah, but
it's a different conversation, I guess.
yeah, you know, this efficiency of a solar panel is, I think of it in a way as a little bit of a red herring in that you'll never get a solar panel producing full power,
No.
you know,
Yeah.
so you've got to accept they're a lot less. And with wind turbines, they're quite a bit less, is very, you know, positional dependent.
If you have a system, I forget what you called it, where if there's a power cut, the house still has power.
Yeah, yeah.
And if the system is joined in, for example, to a wind turbine and the wind is blowing hard,
Yeah.
will the batteries overcharge?
No. What happens is we put a controller in big enough to take care of what comes from the turbine and what you would use in the house, so that controller will always manage it, and it will just shut down the output. If the voltage goes up, the inverter for the wind turbine would shut down, because at 262 volts they have to shut down anyway. That's a requirement. So you won't get them overcharging. It will cut it.
I'm
Yes, conscious of the time.
conscious of the time. So if you could show your appreciation.